Welcome to Chapter 12, Section 3, called Congruent Triangles. This is for Integrated Math 1 or IM 1. So just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt, because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. So we're starting to look at congruence here, and we're going back to transformations. So all of section 6 is about transformations. And you can see over here on the notes page, I have these three transformations kind of shown. These are the rigid transformations. And what rigid means is I'm not changing the size or the shape of a figure. I might simply move it around a coordinate grid, or, in this case, it's not a full coordinate grid, but around the grid paper. But I haven't changed the size or the shape if it's a rigid transformation. So the three that we're looking at, we can reflect an object, so we kind of flip it over, or we can think of it like a mirror image. If you look in the mirror, it's you looking back at you, but you're backwards, right? So it's the same image, just backwards. A translation is a slide, so I can slide it, up, down, left, or right. And then I can also rotate an object. So I can rotate it clockwise, going with the clock, or I can rotate it counterclockwise, going backwards. So there's just these three things can happen, and it doesn't change the size or the shape of the object. So when we ask if an object is congruent, we're asking, is it the same size and shape? Not general shape, exactly the same shape. So it can't just be just two general triangles and have that work. They have to be exactly the same size and shaped triangle, or whatever figure we're looking at. So if we look at these two, it looks like I rotated this guy. So he just kind of flipped over. It was laying down, now it's standing up. And I just want to make sure it's 4 long, it's 3 wide. I have 4 tall now, but I can still think of that as long, and 3 wide. So yes, that guy is congruent. They are the same exact rectangle, it just was flipped over. These are not even close to the same shape, so I'm just going to click no. Because that's the first thing we should be checking. Are they even the same shape? These are both triangles. We just need to make sure that they're the same. So the easy way to do that with triangles is look at the base. So it's 4 and 4. and I have 1, 2, 3, 4 tall, 1, 2, 3, 4 tall. So they have the same base and height. It just looks like I scooted one either up or down, you know, depending on which one you're starting with. These are the same shape. They're both circles, but they're not the same size. So these are not congruent. So we're just kind of testing those definitions there a little bit. All right, we're going to look. So we're just going to match up the arcs. So A has 2 arcs. So I'm going to come over here and find 2 arcs. So that's Z. And I'm going to do this in capital letters because it's Alex can be very picky about that between capitals and lowercase. It has capitals here, so I'm going to leave them capitals in my answers. B has 1 arc, so I'm going to come over here and find 1 arc. That's X. And C has 3 arcs, so I'm going to come over here and find 3 arcs, which is Y. So now that I have these, I can also match up the side lengths. So if I have AB, here's AB. I want to go, here's 3 tick marks. I have 3 tick marks here. I'm very picky about the order on this one. Alex is not as picky. I think they should be in corresponding order here as well. So if it's AB, it should be ZX. I believe Alex will let you type in XZ. It's not as picky about that. But I think just for practice purposes, you should always match them up. A goes to Z, B goes to X. Just to get in that habit. AC, so AC is 1 mark. So I know it's going to be this guy here. I want to make sure I put it in order. So I went A to C. I'm kind of skipping over here. So I'm going to go Z and Y. Z to Y. Instead of YZ, I'm literally naming it ZY because A goes with Z, C goes with Y. All right, last one, we have BC. So BC has 2 tick marks. XY here has 2 tick marks, so let's make sure we have B to C, so X to Y. And now we're just going to do that same thing on the bottom here. So it goes A, C, B. So we're kind of going in a different order there. So I'm going from A to C to B. So I'm going to go from Z to Y to X. So Z, Y, X. So just very much so when you're doing this problem, pay attention to the order. The order matters quite a bit. If it's not in the right order, it will not be correct. So pay attention to the order you're typing these in. All right. So on this one, for each figure below, determine by the markings if there's a pair of congruent triangles. If there is, name the congruence and give the property. So this one requires us to kind of come back over here to our sketch pad and look at some notes on triangle measures. And I'm going to turn off the mirroring now. And I'm going to pick a slightly less intense color there. So we're starting, and I can even show you the drop down. We have 4 different things to look at on this one as far as the property that we can choose. So let's take a look at them real quick. I'm going to draw a triangle. Boom, boom, boom. So here's my triangle. And I can use what's called side, angle, side, 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 angle, angle, side, or angle, side, angle. So what this means is I have 2 triangles, and I want to show that one triangle is congruent to the other, like this. So I just copied and pasted these, so we definitely know they are congruent to each other. But what we don't want to do is we never want to trust the diagram. Whether or not they look congruent, all of these look congruent to each other, but we want to be able to trust the given information. So that's very important. Make sure you're paying attention to what you were given. So for side, angle, side, and we call that SAS, side, angle, side, we want to show that 2 sides of one triangle are congruent to 2 sides of another triangle, and their included angle. Included. What that means is in between the 2 sides. It can't just be a random angle. So I have side and side. So I have these 2 sides congruent to each other, and then I'm going to go with these 2 sides congruent to each other. And then we have to show the angle in between these 2 sides. So like the angle that creates the 2 sides. It couldn't be this angle over here because this doesn't say side, angle, side. Like this, side, angle, side. This says side, side, angle, and if you notice that spells a bad word, We don't want to spell a bad word on that one. So no curse words here. So we want it to be this idea where it's side, angle, side, side, angle, side. These two are congruent by that property. We don't have to go through and prove all three angles are congruent and all three sides are congruent like we did on that last one. If we can just prove that two sides are congruent and their included angles are congruent, then they are. The other piece we have, and I'll do this in different colors here as we go, so I'll try green. We have side, side, side. So this sounds, you know, just like it hopefully sounds to you. We have side, 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 and then I'm going to show that the sides are congruent. I know I'm doing a lot of tick marks here, so follow the colors also as you go. Sorry about that. I know there's not 4 tick marks here. Well, technically there are, but I was going with just the green here. So we're showing that all 3 sides of one triangle are congruent to all 3 sides of another triangle. So we can literally go side, 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 side. So these are congruent triangles using that theorem. Then I'll go in light blue here, I guess. We have angle, angle, side. So we can use that one. We can't use angle, side, side. Again, curse word, don't do that one. But you can do angle, angle, side. So with this one, what we want to look at, we have angle, angle, side. And this is 2 angles of one triangle are congruent to 2 angles of another triangle. And it's a non-included side. So it's a side that's not in between the 2 angles. Because it's, if you notice, we're kind of following the pattern here. This is in between, so it's included. This S is not in between the 2 angles, so it's not included. So we have angle, angle, side, like that. So I can go angle, angle, and then the next side. Or I could have gone backwards and gone angle, angle, side. So it could have also been this one. So I can go angle, angle, side, angle, angle, side. Okay, so we're kind of reading it that same way. And then the last one, which I guess I will do in pink here, is this angle, side, angle. So we have angle, side, angle. And this is very similar to side, angle, side, but this guy is the included one. The side is included. So this does mean that we have an angle or a side in between the 2 angles instead of it being after. So this one I could go angle, angle, side, like that. So it'd be angle, side, angle, which we can actually already see that from some of the other pieces that we have there, but I'm looking at just the pink ones. So we have angle, side, angle. Oops. Angle, side, angle. So, and I know that diagram is getting very, very busy there. I started to fill it in. I should have used 4 different pairs there to show the 4 different pieces. But as we work around, we're just looking for one of these properties. And I know I have these on the notes pages, definitely much more separated out than this. I was just trying to get them all to fit on this one screen instead of me having to copy and paste it 4 times. So as we go through and we're looking at this, we're just going to match them up. So this one I have side, angle, side. That's definitely one of our pieces, but I need to make sure that matches on the other one. So this one I have side, side, angle. Uh-oh. And if we do that angle, side, side, that's that curse word. We don't want that guy, so no, not necessarily. We're not saying they're not congruent, but with the given information, I can't prove it. That's all I'm saying, not necessarily. So here we have angle, side, angle, angle, side, angle. So this one does work by angle, side, angle. And I want to actually put these pieces in. So I have A is congruent to D. So I'm going to put these in corresponding order. B is congruent to E. So I'm just reading this A to D, B to E. C would have to be congruent to this F over here. And again, I can even map it and go A, B, C. So I went 1 arc to 2 arcs to no arc. And I can go D, E, F, 1 arc to 2 arcs to no arc. So I can kind of use those markings to help me map this a little bit. Again, this matters. I can't put these out of order or it will mark me wrong. So this order matters. The segment order doesn't always matter as much when you're just doing segment to segment. I think it matters just to practice that idea, but this congruency matters because we have to have them in corresponding order. All right. So down here I have side, angle, side, side, angle, side. So these are congruent by side, angle, side. So we have the pieces there. Now we need to make sure we match it up. So I have G to J, and then H to K. So I have no marking, no marking. K and H have no marking, but so do I and L. So be careful with that. We want to make sure that we're matching them up correctly. But I can see I'm going from one arc across the tick mark, one arc across the tick mark. So I and L are going to match up, and H and K are going to match up. So again, I'm just using those kind of markings to help me map that. G to H, it goes from one arc over across the two. And so I'm going to go one arc across the two tick marks to K. So sometimes that can be a little bit funky when you're figuring that out. Oh, that should be L, sorry. I to L. I to L. Okay, let's go ahead and check. Perfect, okay. And last piece here, I believe we are going to do a little bit of a theorem on this one. So when we're doing these pieces, we want to make sure that we're kind of mapping this. And I'm going to do this over here. We have overlapping triangles, which can be a little bit confusing to look at. So if we can try to separate those triangles, that can definitely be very helpful visually, if we can separate them out. And you know what? I'm actually going to recopy that. Oops. I wanted to do that. Oh, dang it. I'm just not being very good with my mouse right now. All right, I wanted more space. That's what I wanted, like that. So I just didn't give myself very much space there to work. So I was trying to recopy that to give myself a little bit more space. There we go. So now when I'm working on this one, and I'm actually going to expand this out just a little bit if I can, because what they want us to do is match them up. So we can see there's a lot of angle measures in here, and then we have some here that are marked. So when I'm looking at these pieces, what I want to try to do, if I can, boop, I'm going to go like that, and I'm going to go copy paste. And I'm going to just scooch this guy over like this. So I took that triangle off, but then I also want to do the same thing with this triangle. Boop, like that. And I'm going to go copy paste. And oh, dang it, it's not going to let me do it. Why is it not letting me do it? So, well, I'll just outline this triangle here. And that's another thing you can do on your page, because sometimes it's not, you don't have a copy paste tool like what I'm trying to do here. So just by outlining these two triangles, you can kind of see that we have two separate triangles here. I have this one that's kind of going up, and then I have this pink one that's kind of going down. So for some reason it wouldn't let me lasso the triangle twice. I'm not really sure why. So if I go in here and I'm looking at the pieces and I want to match up angle 4 for this first one, well, that's going to be H. That's the only option I have for this one. So I'm just labeling this H. And I'll bring this back down since I'm not using too many of the lasso tools like I had planned. And then 7, if I'm looking at this piece here, because we can see it's this tilted one, this one kind of going up. So that would be angle L. L, and then this other one here, which is not labeled, but it's going to be the last angle of the triangle, so this is going to be I. And now I'm going to look over here, and I have 9 on this one. So we're looking at this triangle that's kind of tilted downward, the pink one. So this is going to be K. 3, well, the only option for that is J. And then I is also over here. And so what we do want to notice on this one is that I is shared. They both, the yellow and the pink, overlap on this angle I or 8, whatever we want to label it. So they're sharing an angle. A lot of the time when we have these overlapping triangles, it's either going to be angles or segments that are shared. So we're going to choose the correct statement below about HIL and JIK. So the triangles have a common side. Well, they kind of share pieces. So they share this piece, they share this piece, but they don't share an entire side. So that's not true. The triangles have a common angle. Well, we just talked about that. They both do share the entire angle here, this angle I. So we're going to choose angle I, or 8, because they relabeled it 8 on here. The triangles have neither a common side nor a common angle. So this is just a visual. They want you to separate this out so that you can see they actually share an angle or share a side. And one of the reasons for that is when we're going through and doing proofs, what I would write on the proof if I wanted to show that those two angles were congruent, I would say angle 8 is congruent to angle 8. Sounds a little redundant because, you know, obviously the same angle, they're equal to each other, but remember in a proof, if I don't state it, it doesn't exist. So I have to state a shared side or a shared angle. So I'd say angle 8 equals angle 8, and this is by reflexive property. So this is a statement, this is a reason that I can use in a proof to show that angles are congruent to each other or sides are congruent to each other. So if we had something like this, this is a very common one, where we have two triangles back to back, well, this is a shared side. So we would use reflex on that one. So they're just having you practice this idea here. So I'm going to go ahead and go, oh, it'd help if I clicked the button. And all right, we are good to go. So